There was a time when science agreed with you. If you had walked into a laboratory in the late 18th century and asked a chemist what heat was, they would not have spoken about vibrating molecules or kinetic motion. They would have told you about a fluid. They called it caloric. The logic was elegant and completely intuitive. Caloric was an invisible, weightless fluid that permeated all matter. When you burned wood, you were liberating caloric. When you placed a hot iron next to a cold block of ice, the caloric flowed like water from the high concentration to the low concentration until the levels equalized. It explained everything. It predicted the expansion of gases. It predicted how engines worked. It was a beautiful theory. It was also completely fictitious. We like to think we have moved past this. We tell ourselves that we discovered the truth, discarded the fluid theory, and replaced it with energy. But look closely at the language you use today. You say you are charging a battery, as if you are filling a bucket with water. You worry about your phone running out of juice. You speak of energy flowing through the grid. You treat energy exactly the way 18th century chemists treated caloric. You have swapped the word, but you have kept the mental model. This is the first intuition you must destroy. Energy is not a stuff. Consider a red sports car speeding down a highway. You say the car has kinetic energy, but where is it? If you disassemble the car, bolt by bolt, will you find the kinetic energy hidden under the carburetor? Is it dissolved in the gas tank? If you paint the car blue, does the energy change? Obviously not. The energy is not a physical component of the car. It is not a coating. It is not a fluid sloshing around inside the chassis. When we say the car has energy, we are using a grammatical shorthand that deceives us. We are turning a property into a noun. It is like saying a tall building has height. You cannot bottle height. You cannot transfer height from the skyscraper to a spoon. Height is just a description of the building's state. Energy is exactly the same. It is a description of the state of a system. It is a number we assign to the arrangement of matter. But because our monkey brains evolved to track physical objects, berries, stones, tigers, we struggle to comprehend a quantity that exists without a physical body. We desperately want energy to be a glowing blue liquid, because that is something we can hold. But the universe is under no obligation to be holdable. The fluid you imagine is a ghost of a dead theory, haunting your understanding of reality. And once you realize there is no fluid, the question shifts: if energy isn't a thing, why does the number never change? To understand what we are actually doing when we talk about energy, we have to look at a room that doesn't exist, inhabited by a child who cannot be stopped. Richard Feynman used a parable to explain the true nature of energy conservation. He imagined a child named Dennis, a tireless, slightly chaotic child who had a set of 20 wooden blocks. These blocks were indestructible. They could not be divided. Every day, Dennis's mother would come into the room and count the blocks. And every day, the number was exactly the same, 20. One day, she enters and finds only 19. She looks around and finds one under the rug. 20. The next day, there are only 18. She notices the toy box is locked. She knows the weight of the empty box is 15 ounces and that each block weighs 3 ounces. She weighs the box. It now weighs 21 ounces. She does the math. $21 minus 15, 3 equals $2. 2 blocks are inside. 18 plus 2 is 20. A few days later, she finds only 15 blocks. The window is open. She looks outside and sees 5 blocks in the muddy pond. But the water is murky. She can't see them. So she measures the water level. She knows that each block raises the water level by 1/4 of an inch. She calculates the displacement. The math returns a 5. 15 plus 5 is 20. This is the Dennis protocol. And this is exactly what physicists are doing. Notice what happened in that room. As the experiment became more complex, the mother stopped seeing the blocks entirely. She was looking at the weight of a box. She was looking at the height of a water line. She was looking at abstract measurements that, on the surface, had nothing to do with wooden blocks. But she had a formula. She had a set of rules that allowed her to calculate a number. And as long as that number always added up to 20, she convinced herself that the blocks were still there. This is the uncomfortable truth Feynman wanted us to see. In the real world, we do not have blocks. We have no physical objects that we can point to and say, that is a unit of energy. Instead, We have a series of disparate, seemingly unrelated formulas. We have a formula for the motion of a weight $1, $2. We have a formula for the height of a ball in a gravity-filled $mgh. We have a formula for the heat in a gas, the tension in a spring, the charge in a capacitor. These formulas look nothing alike. They measure different things: velocity, height, temperature, voltage. But when we calculate them all and add them together, we get a number. And tomorrow, when we run the calculation again, we get the same number. We call this the law of conservation of energy. But look at what it actually is. It is a mathematical bookkeeping trick. We have decided, as a matter of faith supported by observation, that there is a total sum that never changes. When we see a ball stop rolling, we don't see the energy disappear. We desperately scramble to find where the missing blocks went. We find them in the vibration of the floor atoms. We find them in the sound waves in the air. We find them because we refuse to let the number be anything other than 20. Energy is not the stuff in the room. Energy is the sum at the bottom of the ledger. It is a numerical abstraction that stays constant while the world changes shape. We aren't tracking a substance. We are tracking a persistent mathematical coincidence. But if energy is just a number we've made up to balance the books, why does that number change depending on how fast you're running? If energy were a real, physical substance like a pile of gold or a gallon of water, it shouldn't matter who is looking at it. A gallon of water is a gallon of water whether you are standing still or driving past it in a car. But energy doesn't work like that. Imagine you are standing on a train platform. A high-speed locomotive screams past you at 200 miles per hour. To you, that train possesses a terrifying amount of kinetic energy. If it hit a wall, that energy would be converted into heat, sound, and the violent twisting of steel. The number in your ledger for that train is massive. But now, imagine you are a passenger on a second train, traveling on a parallel track at the exact same speed. You look out the window. The other train appears to be hovering right next to you, perfectly still. You could reach out and touch it. To you, the train's velocity is zero. And because its velocity is zero, its kinetic energy relative to you is also zero. Where did the energy go? If energy were a stuff stored inside the train's atoms, it would still be there. But it has vanished. It has been deleted from the universe's ledger simply because you decided to start running. This is the moment where your intuition should begin to feel the strain. We are taught that energy cannot be created or destroyed. Yet here we are, destroying it just by changing our point of view. This is because energy is not an intrinsic property of an object. It is a relational property. It is a value that exists only in the gap between the observer and the observed. Think of it like distance. A map might tell you that two cities are 100 miles apart, but that 100 miles isn't a physical object buried in the dirt between the cities. It is a relationship between 2 points. If you move one of those points, the distance changes. When we say an object has energy, we are actually describing how that object relates to the rest of the universe. A rock sitting on a cliff has potential energy, but only because the earth is beneath it. Remove the earth, and the energy evaporates. A flywheel has rotational energy, but only because its parts are moving relative to its center. This reveals a profound insecurity in our understanding of reality. We rely on energy to be the bedrock of physics, the one thing that stays the same while everything else changes. But we have just seen that the amount of energy in a system is entirely dependent on who is doing the measuring. If I can make energy appear or disappear just by tilting my head or changing my speed, then energy cannot be the fundamental substance of the universe. It is too fragile. It is too dependent on the observer. This leads us to a deeper, more haunting question. If energy is just a shifting, relational number that depends on our perspective, why does the universe bother to conserve it at all? Why is the Dennis protocol so consistent if the blocks themselves aren't real? To find the answer, we have to stop looking at the objects and start looking at the fabric of time itself. For decades, physicists treated the conservation of energy as a divine decree, a rule written into the fine print of the universe without explanation. We knew the number stayed the same, but we didn't know why the universe was such a meticulous bookkeeper. The answer didn't come from a lab, but from a mathematician named Emmy Noether. In 1915, she uncovered a truth so deep that it makes most of modern physics look like a mere consequence. She proved that every conservation law is actually a mask worn by a deeper symmetry. Think about a game of pool. If you hit the cue ball into the rack of balls today, they scatter in a specific way. If you come back tomorrow and hit that same shot with the exact same force, the balls will behave identically. The rules of the table do not care what time it is. This is called time translation symmetry. Noether discovered that because the laws of physics are symmetrical across time, meaning they don't change their character from one moment to the next specific. I see quantity must be mathematically conserved. We gave that quantity a name. We called it energy. This is the ultimate intuition killer. You think energy is the engine that drives the universe forward. You think it's the spark in the cylinder. But Noether's theorem suggests the opposite. Energy isn't a thing that causes change. It is a mathematical shadow cast by the fact that the laws of nature are stubborn. If the strength of gravity shifted slightly every Tuesday, or if the charge of an electron drifted as the months passed, energy would not be conserved. It would bleed out of the universe, or settle into it from nowhere. Energy exists only because the universe is boringly consistent. It is a measure of the universe's own persistence. We aren't tracking a fuel, we are tracking a symmetry. It's as if you were looking at a perfectly mirrored room. The symmetry of the reflections creates the illusion of depth and objects where there is only a repeating pattern. But this realization carries a terrifying price. If energy conservation is tied to the symmetry of time, what happens when that symmetry breaks? What happens when the room of the universe itself starts to change its shape? If the table moves while the balls are still rolling, the math of the Dennis protocol begins to fail. We have spent centuries convincing ourselves that the law of conservation of energy is absolute. We have built our civilizations on the Dennis protocol, certain that the blocks are always there, somewhere, if we just look hard enough. But this is the moment where the floor falls out from under you, on the scale of the entire universe. Energy is not conserved, the ledger does not balance. The blocks are simply disappearing. To understand why, we have to go back to Noether's theorem. Remember, energy is only conserved because the laws of physics are symmetrical across time. The pool table must stay still for the math to work. But we live in a universe governed by general relativity, and our pool table, the fabric of spacetime itself, is expanding. Imagine a single photon of light traveling toward us from a galaxy billions of light years away. When that photon began its journey, it had a specific wavelength and a specific energy. But as it traveled, the space through which it moved stretched. As the space stretched, the photon's wavelength stretched with it. This is what astronomers call cosmic redshift. By the time that photon reaches our telescopes, it has been stretched into a lower frequency. In physics, a lower frequency means lower energy. The photon has lost blocks. In a local system like a lab or a solar system, we would scramble to find where that energy went. We would check for heat, for friction, for hidden vibrations, but on a cosmic scale, there is nowhere for it to go. It isn't transferred to the expansion of space. It isn't stored in the vacuum. It is just gone. Because space is changing over time, the time translation symmetry is broken. And when the symmetry breaks, the conservation law it supports evaporates. This is wrong moment for most people. It feels like a betrayal of the most fundamental rule we were ever taught. We are told the universe is a closed system, and in a closed system, you can't lose anything. But the universe is not a box. It is an expanding process. The Dennis protocol fails because the room itself is growing, and in the growth, the math of 20 blocks no longer applies. This reveals a chilling truth about the nature of our reality. Energy isn't a fundamental, eternal pillar of existence. It is a local phenomenon. It is a convenience of our perspective, a rule that only holds true as long as we don't look far or stay too long. We are living in a temporary pocket of consistency, clutching to a law that the universe ignores on its grandest stage. If energy can just vanish into the stretching of space, then it cannot be the source of anything. It is merely a constraint, a set of walls that define what is possible in our small corner of the dark. If energy is not a substance, and if it isn't even universally conserved, then what is it actually doing here? Why does it feel so important? The answer is that energy is not the cause of events, it is the constraint on them. We often speak of energy as if it were a permission slip. We say, I don't have the energy to do that. Or this machine requires energy to run. This framing suggests that energy is an active ingredient that we add to the world to make it move. But physics suggests the opposite. Energy is a wall. Think of the universe as a vast sloping landscape of possibilities. Every atom, every star, and every cell in your body wants to roll downhill toward a state of higher entropy, toward total chaos and equilibrium. The only reason the universe hasn't already reached that state, the only reason you exist as a structured being instead of a lukewarm cloud of gas, is because of the Dennis Protocol. The conservation of that abstract number acts as a prison. It forbids certain things from happening. A ball cannot roll up a hill on its own, not because it lacks fuel, but because the ledger won't allow the number to change. The universe is a giant accounting firm, and its only job is to ensure that no transaction occurs unless the math remains perfectly balanced. This changes our understanding of work and power. When you use energy, you aren't consuming a resource. You are simply taking a concentrated pocket of that abstract number and spreading it out. You are moving blocks from a high-density area like a battery and scattering them into the environment as heat and sound. The energy is still there, the sum is still 20, but it is now so dispersed that it can no longer be used to hold back the tide of chaos. We don't live on energy. We live on the delay of its inevitable spreading. We exist in the friction caused by the universe trying to balance its books. When you look at a flame, you aren't seeing the creation of light. You are seeing the collapse of a structure. The energy being released is just the bookkeeping entry for that collapse. It is the sound of the prison gates swinging shut on another possibility. We are not the masters of energy. We are the inhabitants of its constraints. We are the patterns that form in the water as it pours through very narrow, very strict mathematical pipe. We are left with a reality that is far more haunting than the one we started with. We began by looking for a substance, a fluid, a spark, a stuff that makes the stars shine and our hearts beat. We wanted something tangible to hold on to. But we have followed the trail to the edge of the map, and the substance has dissolved. In its place, we have found only a ghost. Energy is a shadow cast by the stillness of time. It is a mathematical bookkeeping entry that vanishes if you run too fast or look too far across the cosmos. It is a number with no physical body, yet it governs every movement of every atom in existence. This is Feynman's uncomfortable truth. We have designed a world around a concept we cannot define. We are like the mother in the Dennis Protocol, staring at the water level and the weight of the box, convinced there are wooden blocks hidden somewhere, even when we can no longer see them. But perhaps there is something more profound in this abstraction than there ever was in the idea of a fluid. If energy were just a substance, it would be finite, mundane, and mechanical. But because energy is a symmetry, it means our existence is inextricably linked to the very structure of time and space. The fact that you can pick up a stone and throw it is a direct consequence of the fact that the laws of physics are the same today as they were yesterday. Your ability to move is a testament to the universe's own terrifying consistency. We live our lives inside a giant, invisible ledger. We are the ripples in the sum. We are the temporary arrangements of a number that refuses to change. Even as the world around it transforms from fire to ice, from stars to dust, we may not know what energy is, but we know what it does. It binds the future to the past. It ensures that the universe remains a place of logic rather than a place of whim. When you look at a distant star or the person sitting across from you, don't look for the glow of energy. Look for the silence of the math. Look for the invisible constraint that holds the chaos at bay. We are not made of stuff. We are the debt that the universe has yet to settle. We are the bookkeeping entries that make the whole system balance. And in that realization, there is a cold, mathematical awe. We are the living proof that the universe has a memory.